mnemonic which will help the user easily understand what the instruction is. So, but at the same time, the processor doesn't understand anything about this. Now, the assembler will convert move A to this form. This is what the processor will understand. Now, here we have the example mnemonic. When I'm writing, it is the opcode plus operands. So, the general form goes like this. So, first column you have label, and all of you are already aware of these things because we have written many assembly level programming programs. Opcode, operands, comment. We have here again is the label. Again is the label, add is the opcode, A is the operand, and this is the immediate value which we are trying to move it to the accumulator. So, and have the sample code given below using 8051 assembly language. So, this is the label delay and move R0, 255. That means load the register R0 with 255 and then decrement R1 and loop until R1 is equal to 0, jump or not equal to 0 to R1. R1 is decremented if the condition R1 is equal to 0, as long as R1 is equal to 0, it goes back to the delay and repeats this. And this is another example. Here we add the label with the name delay. Now I don't want something like label as the delay. Now what I'm doing here is I'm writing the address itself directly. Now this is putting the desired address first, and then we are writing the memory. And here the address I cannot tell because the address will be chosen by the assembler. But here as a user you can define the address from where this procedure or the subroutine should start. So otherwise rest all is same. Here it was assembler which was deciding the address of this particular label, but here it is the user who is writing it. org is an assembler directive which tells I want this particular code to be starting from this address. Next, assembly language program written in assembly code is saved with the extension .asm. All of you are very much clear about this, and .src, and sometimes we also use .a. And how to write the assembly programs? You can use simple notepad, wordpad, or even the IDEs, integrated development tools like the Keel software, which you people have used in order to write the assembly programs as well as the embedded C programs. Now, if the program which you are writing is very big and too complex, then it is preferred to use the modular programming approach. That is, what is modular programming approaches? Instead of developing one big program, very large program, so it is always advised to write the programs, many number of smaller programs, because that way it will be much easy to code, debug, and also to alter the program. Now, how do we convert the source file into the object file? We have the source file, source file 1, source file 2, so which is .src or .asm file. So two module 1 and module 2 written using the assembly language. Now we have the assembler which will convert that into an object code. So I have the first object code, second object code, and in addition to this we have something called as library files. Now to this object file the libraries are linked by using the linker, and then linker or locator. After the linker links all the required libraries with the object files, the locator will go for locating the program, so this, and then absolute object file is generated. Now, and using this absolute object file, so the object file to X file converter will convert it into an X file, which is an hexadecimal file which can be loaded into the microcontroller for execution. Now, library file creation and usage. I told here there are library files which are also linked with the object files. Say I'm writing a program and I want to make my program itself as a library. and make it available for the other object programs to use it at later point of time. Now and that is possible. So what I can say is libraries are the specially formatted ordered program, a collection of object modules that may be used by the linker at later time. So and all libraries they have the .lib extension, and you can say this is some kind of source code hiding technique, because I am writing some program and I want, if I make them available as a library, the program is available and it provides the service, but I cannot see how those programs are written. So this is what is the technique of source code hiding. Now and Keel software also has this lib51 from Keel is an example for the library creator. Even in Keel you can create the library by using this lib51. Now linker and locator is another software utility responsible for linking the various object modules in a multi-module project and assigning the absolute addresses to each module. So what linker does, linker links all the object files within the project and also external libraries to it, and what locator will do is it will go for assigning the absolute addresses to each module so that they can get located in the memory. So without locator it's not possible for the compiled object program to get located inside the memory. So linker program, as I already told, combines the target program with the library routines, and during the process of linking, absolute object module is created, and this absolute object module is the input for the X file creator, and that X file creator, using this it will generate an X file which can be used for dumping into the code memory of any processor or controller, microcontroller. We have such linker and example for linker and locator. So Keel software BL51 is the example for the linker and locator. Next, object to X file converter. So this converts the object code into the machine code, and which can be dumped into the code memory of the processor or the controller. We have the example here. It varies from depending on the target processor or controller make. So for all Intel processor it generates something called as Intel X file, and for all Motorola processor it generates something called as Motorola X format. And the hexadecimal representation of the target applications, what the processor knows how to execute them. So we have the example again from the Keel software. The object to X file converter is HQ51. HQ51 is the one which does the object to X file converter inside the Keel software. And what are the drawbacks of assembly language based development? One is high development time, so it takes more time for developing the program using assembly language, because the program length will be very large. And then developer dependency, that means you will be using assembly level programming language which is confined only to one target processor or controller, and non-portable because again it confines to one processor or controller. So developer dependency means so the dependency will be there. So the developer will develop the program only in assembly level language, and any of the functions which he needs to do, it has to be in the assembly language itself. Next, high-level based development model. So here you can go for using the high-level programming languages like C, C++, or Java, and along with this you got to use the cross compilers also. So why cross compilers here? Because you develop the program using these high-level programming languages using one target processor, and you're going to make them execute on a different target processor. Hence we require the cross compilers here. So and majority and the most commonly used high-level language for embedded firmware development is the C programming language, and C as well-defined and easy-to-use high-level language with extensive cross-platform development tools. And nowadays we have the cross-compiler support for even C++ programming language also. And the conversion of the source file written in high-level language to object file is done by the cross-compiler, whereas the assembly language-based development, it is carried out by an assembler. Now this is what we do. So these are the programs now written in high-level programming language like C or C++, and what we are using is the cross-compiler. So cross-compiler generates the object file. So and linker is used for linking the libraries with all the object file, and then again we have the object to X file converter, which will give you the X file, which can be dumped into the code memory of the processor or the controller. Now, advantages of high-level language based development: one is reduced development time and the developer independency. That means the developer he can develop in any one programming language, that is C or C++ or Java. And portability, because the program which is developed using one target processor or controller with a cross compiler, it can be made to run on a different target processor or controller. Drawbacks of high-level language based development: cross compilers are available for high-level languages, may not be so efficient, and investment required for high-level language-based development tools. If you're using the assembly level programming language, you don't have to do additional investment. But if you're using the high-level language for developing the applications, embedded firmware, so then you may have to spend on the development tools. Additional development tools may be required. So mixing assembly and high-level languages. So this I've already told you in one of our topic from the second module, third module, I think, third or second module. It was writing ARM assembly code and optimizing. So that time we have understood calling the function from ARM code, ARM assembly code, from ARM assembly code calling the C function, or from C program calling the ARM assembly subroutine. So same thing here. Now we go for mixing the assembly with the high-level language. Now we are using the high-level language for as the main language for doing all the program, and in between we go for mixing the assembly language along with the high-level programming language, and vice versa is also possible. So when you're using assembly language as the main programming language, so small complex functions can be written by using high-level language. So these are the three types of mixings that are possible: mixing assembly language with high-level language, mixing high-level language with assembly language, and inline assembly programming also. When you are writing the C program, so the assembly modules can be substituted along with the C function. So that is what is in inline assembly programming. Next, mixing assembly with high-level language. This I think I have already told you people in the third module, that is writing and optimizing the ARM assembly code. So especially when you go for mixing the assembly with high-level language, when you want to take advantage of speed and optimization, code optimization offered by the machine code, so then you can go for mixing the assembly code with the high-level language. Next, now how do you mix the assembly code with the C? So there are directives which you can use in order to do this. Use src directive. How to use src? This is the syntax. So at the top of the file you have to say #pragma src. src stands for the extension of assembly programming language .src, so that the compiler generates .src file instead of a .obj file. Now if you include this, now when you by including this assembler directive, src directive. If you compile your C program, instead of generating an object file, it will give you .src, that is the assembly level program it gives. Now take this assembly level program and you can add the assembly code in between wherever you require, and then rename this .src file to .a51 file, and you can assemble this .a51 file to get it converted into the machine code. Now how do you mix high level language with the assembly language? So that is also possible. Now the entire source code is planned in assembly code for various reasons like code optimization, all these things, but some portion of the code may be very difficult and tedious to code in assembly language, and that part of the code you can go for writing in C programming language and embed within the high level language. So example is this a built-in graphics library function and string operation supported by C. Now say these things, graphic library functions you don't have in assembly language, and string operations also not available in the assembly language, and these things can be built into the assembly program by writing the C functions. So inline assembly is another technique of inserting the target processor or controller specific assembly instruction at any location of the source code written in high level language C. So this avoids the delay in calling the assembly routine from C code. So because since you are doing the inline substitution, because macros are the inline substitutions, so and it's much faster than calling the procedures. So same thing. Now here when I say inline assembly, it is a small piece of the assembly code which is inserted within the C code. Now C51 uses the keywords pragma ASM and pragma end ASM. Now the small piece of assembly code which you are inserting into the C program, it has to be enclosed between these two, pragma ASM and pragma end ASM. Now C versus embedded C. C programming language is used for general purpose programming language for writing varieties of application, but embedded C programming used for I can say embedded C is a subset of the C programming language which is specialized for developing the firmwares for the embedded programs. Yeah, now this is what I told. It's a subset of conventional C language. And the same ANSI C library implementation is always tailored to target processor or control library files in embedded C. They supported cross compilers for particular embedded C language. Now these are the differences here. Now C is a general purpose programming language, whereas embedded C is an extension of the C language and used to develop the microcontroller based applications. C language is hardware independent, embedded C is hardware dependent, and standard compilers are available for compiling and executing the program, but here we have the cross compilers which will convert the program written on one particular hardware or microcontroller to execute on another target processor or controller. So one is readability, modifications and bug fixing, etc. are very easy, but here readability, modification, bug fixing is very difficult in embedded C. So compiler versus cross compiler. Compiler, what it will do, it is any program which you write on the target processor architecture, say for example Intel x86 or Pentium. So there that program is compiled and it will make that program executable on that particular target processor or architecture. Now when I say, and compilers are also called as native compilers, because what they do, so they generate the machine code for the same machine on which it is running, whereas the cross compilers are cross-platform development applications. So what they do, they make the program written on one target processor to be executable on the other target processor. Say for example, so all these days we used to compile the ARM assembly code and embedded C programs in the Keel IDE. So and every time we used to write the assembly code or the embedded C program, we used to write the select the target device as LPC2148. But the development what we are doing is on using your the system desktop system processor or the laptop system processor. So development is done there, but using the cross compiler, you are compiling it to make it run on a different target processor or controller. Yeah, this is the end of the module 4 we have completed here, and the last thing that we understood was embedded system firmware design and development, how it is done. Thank you.